Hello, welcome to day 3. So on day 3, we have learning target 6, which is I can analyze and describe the characteristics of a piecewise function. So notice this is a function that's new to us. It's not linear, it's not exponential or quadratic. However, a piecewise function is a function that's made up of different functions. So if you see this example below, I have multiple linear functions in example 1 that make up the piecewise function. I can also show you an example such as example C right here. This is also a piecewise function because it has 3 different linear segments that combine to make it a piecewise function. So we're going to analyze piecewise functions today. And when we look through how we can describe the characteristics, we have a few. We have general shape, which we can do, where it's increasing or decreasing, we've seen before, maximum or minimums, and symmetries we've talked about. What we haven't talked about is rate of change, and so that's what we're going to do a mini lesson on right now. So the rate of change is a comparison of one quantity to another, or one amount to another. Okay. It's also informally known as slope with units attached. Slope is a previous concept that we'll continue to explore, and I know you explored in pre-algebra. And so when we describe the rate of change, so the comparison of quantities, we can use the following words. We're either going to say the rate of change is not constant. So, for example, if we're talking about like an exponential function, that's not constant. The comparison of one quantity to another does not stay consistent, okay? Or we could use the word constant, okay? And within our constant, we either have a positive constant rate of change, a negative, or 0, okay? And so just to give you an idea, if it's a constant rate of change, it'd have a positive slope. If it's a negative rate of change, it means things are decreasing. And then 0 means horizontal, meaning there's no change. Okay? So example 1 says describe the rate of change at each position. So we have 5 different positions. Okay? And I'm just going to use the highlighter to help us through this. So let's look at where there should be a positive rate of change. And it's constant everywhere. So segment 1, 3, and 5. So I'm going to do this right here. 1, 3, and 5. Segment 1, 3, and 5 have a positive, and you can write that word out if you want, positive constant rate of change. I'm going to abbreviate it ROC. Okay? And then I can also let's look at segments 2 and 4. What do I notice there? In segments 2 and 4, I have a constant, oops, that's not how you spell it, rate of change, and it's 0 because it's a flat line. So it's not increasing or decreasing. The other piece of this is looking at the domain and range. Now notice here it says we want the domain units and the range units. So when I look here on my x, I have time. Remember, domain is x. The range units, remember my y variables, is the temperature. And if you want to be specific, you could say in degrees Celsius. Okay? So, as you can probably assume, not all functions follow a linear, exponential, or quadratic model. However, we can still describe key characteristics of a function. So again, one more time, key characteristics are general shape, where it's increasing and or decreasing, where there's maximum or minimums, what we know about the rate of change, and or what we know or recognize about symmetries. So on this graph represents the Chicago population from about 1820 to about 2000. So what I want you to do is pause the video and try to identify 4 key characteristics. What can you tell me about the shape? What can you tell me about where it's increasing or decreasing? Is there a maximum and or a minimum? What do you know about the rate of change? Are there symmetries located anywhere? So I want you to pause the video and try to list 4 characteristics that describe this graph. Okay, so hopefully you felt comfortable identifying 4 key characteristics. What I want to point out is that we have to be specific. So notice when I talk about the population increasing between 1830 and 1950, I'm using the title of the graph and I'm using specific dates. It doesn't have to be exact. So if you said like 1820 to 1950, that's okay. The idea is that you're telling me where it's increasing. Same for decreasing. Maximum population, you're telling me it's like the x coordinate. So in 1950, it is 3.6 million. Again, approximating is okay. But you can't just say max population. We need to be more specific and say maximum population of 3.6 million in 1950. Same for minimum population. Now notice I didn't write 0 because we knew there's more than 0 people in Chicago. We didn't have enough. We knew it got really close to 0, but not exact. So that's why I didn't list an exact number there. I also included one characteristic could be, you could say between 1830 and 1930, the graph looks exponential, right? It's curving. And then all of a sudden, after like approximately 1930, 1950, it decreases. So again, we have to be specific because it's not exponential, the whole graph, but a segment, a piece of the graph is exponential, okay? You could have said, from, where it decreases between 1950 and 1990, it looks linear. That's appropriate too. So again, you just have to be specific when we list key characteristics. Okay? So the next piece is analyzing graphs, right? And so when we analyze graphs, we have different type of vocabulary we can use. Okay? So if we want to talk about the shape of a graph, you could say, obviously it's a line. If it's linear, we could have a parabola. If it's quadratic, you could call it a shape or a curve if it's exponential, or you could call it a piecewise function if it's made up of different functions. If you're going to tell me it's increasing or decreasing, you need to say between blank and blank, so you need to give me a location. Okay. If you're going to talk about a maximum or minimum, you need to say at a point. So you need to say it's at x comma y. Okay. You could also talk about the rate of change if you were analyzing it. So you could say it's constant. And if it's constant, I want you to tell me if it's positive, negative, or 0. Okay. Or not constant. So you could also say there's not a constant rate of change. Okay. If it's symmetric, we need to say through the vertex. Okay. And so what's going to happen now in these remaining examples is each example represents a function one of our 4 ways, right? So remember, we can either have an equation, a graph, a table of values, or word problems. And we're not going to give you word problems just now. So we're going to give you a function as an equation, a graph, or a table of values. And what we have to do is you're going to go through and you're going to name it based on what you know. You're going to list the domain and range, and you're going to analyze it, and you're going to list 3 or more characteristics. So you get to pick which of those 3 characteristics you want to talk about, okay? So let's do the first one together. So we're given a graph, okay? So we're going to recognize the shape of it. So hopefully you're like, oh, I know the shape's a parabola, so therefore I know it's a quadratic function. Okay, the domain and range. So again, domain, negative infinity to positive. Range is min to max. So when I look here, this is the 0.22. So my minimum y value is 2. My max is infinity. Okay, and then let's talk about some characteristics. So one thing very special about a quadratic is the shape is a parabola. So we're going to tell me the shape. Okay, so we've talked about that. Also, I want to talk about this point right here. So we would say a minimum at, and we're going to label the point. So 2, 2. Okay. Maybe you want to talk about symmetry, and you could say symmetric through the vertex. Okay. That'd be acceptable, right? Because remember, symmetry means I can fold it on that dashed line, and I'd have the same graph. Maybe you wanted to talk about increasing or decreasing. You can do that. Maybe you want to tell me it decreases from negative infinity to 2, and it increases from 2 to positive infinity. It's another option. Okay, you would just be specific. So what you're going to try is these remaining 3 examples. We're going to name the function, tell me the domain and range, and tell me 3 or more characteristics, and be specific.